Okay, to look at whether we are going to have a best representation of these two sets of data, obviously your three choices are going to be mean, median, and mode. And I had somebody ask earlier today, we haven't ever had something that we thought mode was the best representation. That's really not going to happen unless like 75% of the data is all the same question or is all the same number. So typically we're going to say that the mean or the median is going to be our best representation of the data. For number one, what do you think? Mean or median or mode? What do you think, Brian? Well, then come sit right here beside Tyler. Because if you can't read that, then you can't read the other things we're doing today. Lincoln, what do you think? You think the mean is the best representation of number 11? We just guess all three? Anybody have a reasonable explanation to what they choose? This is 66. If you compare it to all the other values, you are definitely going to have an outlier with 66. And anytime there's an outlier involved, median is going to be your best. For number 12, Brian, seriously, right here, so you can see. Get your things and move. Kyle, what do you think about number 12? Mean. Because all of them are pretty close together. Now, for what we're doing today, we're going to be talking about our standard deviation. And we're going to be doing the standard deviation of samples and of populations. But one of the things that you have to keep in mind is that if you're doing the standard deviation, and we're going to have our calculator, it's wonderful that we actually have the ability to have our calculator find our standard deviation, but you have to choose between whether it's the standard deviation of a sample or whether it's the standard deviation of a population. So whatever set of data, not only do you have to know how to calculate it, but you also have to choose whether you have the standard. Everybody's yawning. You're killing me. Whether it is population or a sample. Now, Clarissa calculates the average number of pineapples in 25 cans of pineapple. What do you think, Ned? We're determining whether that is a population or a sample. That is a sample because it's 25 cans of pineapple, all the pineapple we have in the world. No, not possible. Brooke, what do you think about the IRS calculates the mean income per household? That's going to be a population. Carrie, Middleburg Elementary School calculates the average heights of all of its students. Population. Lincoln, members of the football team want to compare their times in the 40-meter dash to those of the rest of the conference. If you're talking about comparing to a larger group, we have our scores and then we're going to compare them to a larger group. See how that's a sample? Anand, if we ask 100 random people in the mall for their opinions on education, because are there only 100 people in the mall? Probably not. Jake, the NFL compares the yards per game allowed by each team's defense. Yes, very good. There was somebody earlier today who had trouble with that one just on the mere fact that they, it was more of a football issue because they felt like if you're talking about defense, it should have been a per player thing, but it is, since it is all the teams. You're right, it's a population. Tomas or compares the populations of every state. What do you think, Gabby? Population, because it's all of them, right? Perfect. And Arjun, if we ask 400 random people their favorite sport for the season, what do you think? Now, in terms of our margin of sampling error, what we're going to do is use the formula that we went over yesterday of plus or minus what? Square root of n. Very good. So, Mackie, if I'm trying to find the margin of sample error for the first one, it's going to be plus or minus 1 divided by the square root of what? 5669, 5,669. So then when we convert that and find our answer, you got what? 33? Yeah, good. And then Jacob, if I want to convert that to a percent, what do I have to do? Perfect. We're going to move it over twice, which gives me a percent of 3%. Now, that's how you find the margin of sampling error. How do you find then, Stephen, the interval with that information? This is our margin of sampling error. What was the original percent that we had? 31. So what do we do with the 1.33? If you're trying to find that interval, guys, what you have to do is you have to take the 31 and subtract 1.33. And then you have to take the 31 and do what? Good. So if we subtract it, what do we get? 6.7. So the lower interval, or the lower bound of our interval, it's 29.67. And then it goes to, what's 31 plus 1.33? 33%. So 32.33%. In a survey, if we're trying to find the margin of sampling error, I'm going to do what, Olivia? Square root of 4,213? Savannah, what's that give you? Oh, I'm sorry. I'm so used to Savannah being right there. Carrie, what's that give me? 0.01. Can I have one more decimal? Anybody get 2 decimals? What should it be? 0.0154? I want you to go 4 decimals so you have to hundredths place in the percent. At that point, Brian, how do I convert this decimal to a percent? 2 places over, so it's going to be plus or minus 4%. And Jacob, what am I going to do in order to find that interval again? Okay. So that's the higher part of the interval. How do I get the other half? And that gives me seriously. Okay.